In this video we're going to learn about another type of conic section, which are sections which are circles and ellipse. Circles and ellipse are related to one another, so that's why we're going to discuss them really at the same time. Circles first, then ellipse second. So if we think about what a circle is, everyone should understand what a circle is and how you create a circle. You take a center, which is just a point. You go a certain distance away from that center, which we call the radius, and then we sweep that 360 degrees around to create our circle. And all the points that are the exact same distance away from that center create my circle. So the set of all points P in a plane that are equidistant from a fixed point called the center are the points that make up the circle, that fixed distance being the radius. Pretty simple. The big thing that you're going to have to get used to is what the equation of a circle is, which you really should be familiar with a little bit from trigonometry already. But anyway, if we're looking at a circle that's centered at the origin, and everything we're going to do is going to be centered at the origin to begin with, because these are the easiest ones to work with. So if you're working with a circle that's centered at the origin and has a radius r, the equation of that circle is x squared plus y squared equals r squared. You can see that this equation is different from the equations we were dealing with when it came to parabolas, because both variables are being squared. So if I get rid of some of this, we can talk about this more. So if you think about this equation, x squared plus y squared equals r squared, this is really the same thing as if I said x squared over r squared plus y squared over r squared equals 1. This is going to be important when we talk about ellipse, because this is essentially going to be the form of an ellipse. I can write the same equation here in this form, and the idea is, okay, I still have the two squares, they're added together, they're divided by the exact same thing, and what they're divided by is r squared. So whatever this is, the square root of these two numbers would give me the radius, and the whole thing's equal to 1. You might see both forms. More likely you're going to see this form, but just to show you, there's two different ways to write it. So if I wrote x squared plus y squared equals 4, that's the equation of a circle. That's an equation of a circle with radius 2. But this equation, x squared over 4 plus y squared over 4 equals 1, is also the equation of the exact same circle. So it's something you're just going to have to get used to. So here are some questions. First one, graph and find the standard form of the equation of the circle with center 0, 0 and radius 4. Well, we really just did it. If the center is 0, 0, then the formula should look like this. If the radius is 4, now the one we did before was radius 2, but the radius is 4, then it should be 4 squared, which gives me x squared plus y squared equals 16. So that's the equation of the circle with center 0, 0 and radius 4. Now if you have to graph it, graphing these is not that hard. It's much harder to graph other things that we've done this semester. So the center is 0, 0 and the radius is 4. Well, if you want to count a certain amount of units in the xy plane, horizontal and vertical is the best way to do it. So we're going to go 4 that way, 4 that way, 4 that way, 4 that way. This is where the outside of the circle should be. Do your best to kind of connect these dots. That's my circle. It's not the greatest circle in the world, but it's pretty good. That's the graph of what this circle would look like. 4, 4, negative 4, negative 4. Here's another one. Find the center and the radius of this circle. So this question is basically the reverse of the last question. I'm giving you the equation, and you need to tell me the center and radius. Well, this is in the form x squared plus y squared equals r squared. So the center is automatically 0, 0. And as far as the radius goes, this is r squared. So if r squared equals 10, then r equals the square root of 10. Now, you don't have to do plus and minus, you just didn't do the square root because r is a distance, so it's always positive or 0. So in this case, positive square root of 10. That's it. There's not much to these questions because circles are fairly simple. What we want to spend more time on is the ellipse. So now we want to discuss ellipse. So an ellipse is an oval, okay? So it's very closely related to a circle, except for we don't have the same radius the whole way around. Now definition-wise, it's going to say something like this, which has to do with distances. All our conic sections have to do with distances. So an ellipse is a set of all points P in a plane such that the sum of the distances from P to two fixed points, F1 and F2, which we're going to call the foci, is constant. Now you could read that definition a couple of times and it might not make sense, but let's look at a picture. So here's our point. The definition says that the sum of the distances between this point and two fixed points, these two are the fixed points, these are our foci. This distance plus this distance has to remain constant, which means that if I look at that distance, if I call this A and I call this, no, let's not do that. If I call this triangle and I call this star, okay? That triangle plus star has to remain constant, which means if I take another point here and I look at the distance between this point and this point and this point and this point, I might get different distances, and I might call this, I don't know, smiley face and circle, okay? And I look at smiley face plus circle. While smiley face and circle might be different than triangle and star, the sum of the two distances here and here should be equal to one another, meaning that the sum of any of these two distances should always give you the same value every single time. Even though maybe individually the two distances themselves are different than the other distances, the sum of them should always remain constant. The best way to kind of explain this is to, let me erase some of this. Think about if I put a thumbtack here and a thumbtack here, and this was my string, okay? And I basically tied the string here and I tied the string here, and this was the string here. I'm going to pull my string tight with my pencil so that it comes to a point, so that this is straight and this is straight. And then what I'm going to do is, since my string is tight now, it's fixed here and here. It's not going to move, and the length of the string is not going to change. I'm then going to keep the string tight and just drag it around. And what's going to happen is I'm going to trace out this circle. So as I drag it around, the string is still the same length the whole time, but it's giving me this oval shape. So that's kind of the best way to explain it. Now, it's all great to know the definition of these conic sections, but really what you need to know is how to construct the conic sections. So if we look at this other picture here, we want to think about this picture will help us figure out how we construct an ellipse. The idea is, first you need to know the center. All our ellipses that we're going to start with are going to be centered at 0, 0. And then really what there are there's infinitely many different radii, but there's two radii that you really need to be concerned with. You have a big radius and you have a small radius, okay? And then in between you have every kind of radius in between, but the idea is you have your big radius and your small radius. And because they're not the same, that's why we don't get a circle. Well, if you think about this big radius, if this distance here is A, okay, then this point right here is going to be A, comma 0. And if this distance here is also A, then this point right here would be negative A, 0. These 2 points here are called my vertices. There and there. This axis that basically goes straight across the ellipse and cuts it directly in half, and it's really the bigger axis. You can think of it as like the bigger diameter. okay, that goes all the way across, is called the major axis. And if this is A and this is A, this total distance is 2A. Then we have this small radius, and if this distance right here is B, then this point right here would be 0 comma B. And if this distance here is also B, then this point right here would be 0 comma negative B. This axis right here is called the minor axis. This total distance from here to here is the minor axis, and that should be 2B. So the major axis and the minor axis are really sort of the defining parts that make us build this ellipse. And if we could figure out what A and B are, this small radius and this big radius, and we know where the center is, it's very easy to construct this ellipse. Now there's another point in here that's part of really the definition, which is these 2 points here, which are our foci. In that case, there's a distance from the center as well along the major axis, which we're going to call C, and that distance is C, which makes this point right here C comma 0. This distance here along the major axis is C. That value would then be negative C comma 0. Right? And this is getting kind of busy in this picture, but this is kind of how we're constructing this axis. So we have our major axis, our minor axis. Our major axis contains our vertices and our foci. Our minor axis contains these 2 points, which we really don't have names for. We can call them the minor axis points, but they're based off of B. And we can construct this ellipse this way. Especially if it's centered at the origin, this is fairly easy to do. When it's not centered at the origin, it'll take a little bit more time, but a lot of the pieces fall together the same way. Whichever axis is bigger, and the major axis is actually always going to be the bigger axis, but whether or not the x-axis is the bigger distance or the y-axis is the bigger distance will tell you whether or not you have a horizontal ellipse or a vertical ellipse. Right? If this distance here is bigger, then my ellipse will be more vertical, but the bigger axis is always the major axis. So whether I have a vertical major axis or a horizontal major axis, all depends on what kind of ellipse I'm going to get. A is always representative of the distance for the major axis. So then we look at our formulas. So this is the formula for an ellipse centered at the origin. You can have a horizontal major axis or a vertical major axis, and the key is, where is A squared located? Okay? If I have a horizontal major axis, the horizontal distance is bigger. A is always the bigger value. A is under the x, so that tells me the x-axis is the bigger axis, therefore horizontal major axis. Here the A is located under the y squared. So A is the bigger axis, A is under y, therefore we have a vertical major axis along the y-axis. This A and this B are those 2 distances we were just discussing. These values from this equation are the distances we were discussing. And if you look at it, this equation looks very similar to x squared over r squared plus y squared over r squared equals 1. The difference between this, which is a circle, and this, which is an ellipse, is that these 2 are different and these 2 are the same. And that's the idea of the difference between a circle and an ellipse, right? A circle, you have the same radius all the way around. An ellipse, you have a different radius in one direction as opposed to another direction. So that's how you look at the 2 equations, circles versus ellipse. Something to remember here is that when you're looking at this equation, A is always the bigger number. So you're literally looking to see, is the bigger number under the x or is the bigger number under the y, as to what kind of ellipse do you have. And once you pick out the bigger number, A, then you know what the bigger radius is, and then the other one's the smaller radius, and you can go from there. Now there was another value that we talked about in that picture just a second ago, and that was C. C is not part of this formula here or here, but you can get C. C is the value you use for your foci, and this equation will always help you find C. In that case, it's a squared minus b squared equals c squared. Now be careful, this is a squared minus b squared. You're used to an equation with the Pythagorean theorem called a squared plus b squared equals c squared. But this is a little different. Now there's a reason why this equation comes from what it comes from, and it has to do with using the definition of an ellipse with distances and the distance formula to create these equations. We're not going to go through that. I just want you to get used to looking at these equations and working with them, and not know so much where do they come from. Remember, your length of your major axis is 2a, the length of your minor axis is 2b. The major axis is always the bigger axis. So this is the type of question you might see. Graph and find the standard form of the equation of the ellipse centered at the origin with horizontal major axis of 14 and minor axis of 10. Right away, horizontal major axis tells me my equation should be x squared over a squared plus y squared over b squared equals 1. Whatever I find to be a, it should go under the x squared. So, what are we going to use here? Well, we have our major axis is 14. That's the length of the major axis. In that case, so that's 2a, which tells me that a is 7. My minor axis is 10. That should be 2b. So it tells me that b is 5. So once I got a and b, I plug them in here, and I got my equation. So I got x squared over 49 plus y squared over 25, because you got to do a squared and b squared equals 1. This is the equation of the ellipse. The only other thing the question asked for is that you want to graph it. Well, graphing an ellipse is actually just as easy as graphing a circle. If I make some room here, let's draw a little graph. You know what the big axis distance is, you know what the small axis distance is, and it's centered at the origin. So if that's the case, I look at this and say, okay, here's my x-axis, here's my y-axis. My bigger axis is the x-axis, and that distance is 7. My smaller axis is the y-axis, and that distance is 5. So this point and this point are on my graph, this point and this point are on my graph. Draw your graph as best as possible. It should look like an oval, because there's a bigger distance this way, there's a smaller distance this way. That's it. There's your graph, centered at the origin. This distance here is A, this distance here is B. Let's do another one. Find the coordinates of the foci, find the lengths of the minor and the major axis for this particular graph. So what you're going to have to do is you're going to recognize that this is an ellipse. Okay? Because of the form. This has the form of x squared over b squared plus y squared over a squared equals 1. Now, the reason why I did a squared under the y is because this number is bigger, which means that this has to be a squared. So we want to find the lengths of the major, the minor, and the foci. Well, right away we can label that 9 is our a squared, which tells us that a is 3, and 4 is our b squared, so that tells us that b is 2. And once you get a and b, then that gives you your major and minor axis. So our major axis should be 2a, which tells me 2 times 3, so 6. My minor is 2b, so that's 2 times 2, so that's 4. Those are the lengths of the major and the minor axis. And then we got to get the foci. Well, foci is the c value. Well, we know that a squared minus b squared equals c squared. So that tells me that 3 squared minus 2 squared equals c squared. So 9 minus 4 equals c squared, so c equals plus or minus square root of 5. So that's my c value. Now look at the question. It says find the coordinates for the foci. Coordinates means x, y, right? So this is a number. This is not a coordinate. So is this an x value? Is this a y value? And if so, what's the other coordinate? Well, think about this. This is the bigger axis. The bigger axis is the y-axis. Okay? So my ellipse is going to look like this. C is a distance off the center. So here's C to get my focus. Here, let's change colors. Here's my center, here's my focus. C is this distance here. So if my foci is really on the y-axis, because the y-axis is the bigger axis and foci should always sit on the major axis, this point should have an x value of 0 and then a y value. So this is a y value for this particular ellipse. So if I was to do the coordinates, it would be 0, comma, plus or minus square root of 5. There's 2 points here, 0 square root of 5 and 0 negative square root of 5. This would be the coordinates for my foci. So one more. The equations aren't always going to be in exactly the form you want them to be, and lots of times you have to turn them into the form you want. So for our ellipse, our forms have to be x squared over a squared plus y squared over b squared equals 1, or x squared over b squared plus y squared over a squared equals 1. The key is it's got to be equal to 1. Well, we don't have that here. So I can make it equal to 1 though if I divide by 144. But I got to do that all the way across the board. And if I divide by 144, what I get is 16 over 144, which is x squared over 9, plus 9 over 144, which is going to be y squared over 16, equals 1. Now this looks more like an ellipse that I want it to look like. So now that you start to look at this and go, alright, well, first of all, the bigger numbers has the form of an ellipse, the bigger numbers under the y. So that tells me that the a squared is the 16, the b squared is the 9. If it's under the y, the major axis is the y-axis. So a is 4, b is 3. My length of my major is 2a, so that's 8. My length of my minor is 2b, so that's going to be 6. My foci is a squared minus b squared equals c squared, so that's going to be 16 minus 9 equals c squared. So what's that going to be? 5 again? No, sorry, I can't subtract. 7. 7, so c is plus or minus square root of 7. Now, again, those are numbers, those aren't coordinates. So, major axis is the y-axis. Y-axis is the major axis. My foci sit on that major axis. If that's the case, then the x value has to be 0. And then I get a y. If my major axis was my x-axis and my foci sit on that, the y value is 0, and then I have an x value. So it all depends on where the major axis is, how these coordinates line up. So then that means my foci are going to be 0, comma, plus or minus square root of 7. So that's about it. That's all you can do really with ellipse right now. Eventually what we're going to do is talk about moving an ellipse off of the center being 0, 0. But if you can do it with the center being 0, 0 and know what A and B represent, they represent distances away from that center, then really the center could be anywhere. So we'll have to discuss that one in the future lessons. But right now, this is what we have for ellipse. One thing you're going to see in the textbook is something called eccentricity. Really, that's something that in the long run can be ignored for right now. So any questions that deal with eccentricity, right now you can just skip over those. Or at least that part of the question.